Every single day, 50,000 beds are thrown away in America. That is 18 million mattresses a year, and 80% of them end up right here, buried alive in landfills, where a single mattress swallows 23 cubic feet of space and refuses to die for over a century. But inside every one of these abandoned beds is something that does not belong in the ground. 25 pounds of pure steel. Steel that can be reborn as rebar, as bridges, as skyscrapers. This is the story of the machine that rips them apart. But here is the problem. Fewer than 20% of those mattresses ever see a recycling facility because the job of tearing them apart has always been brutal, dangerous, and almost entirely manual. Until now, a new generation of shredders is changing everything, and the people who run them are racing against a mountain of waste that grows by 50,000 beds a day. For decades, the math was simple and crushing. A single mattress contains around 25 pounds of high-grade steel, 9 pounds of cotton, layers of polyurethane foam, and a wooden frame. But getting those materials back out required something the recycling industry could never afford: time. Workers armed with utility knives and Kevlar sleeves stood over conveyor belts, slicing mattress after mattress by hand. 90% of the disassembly was manual. They ripped fabric, pulled out foam, and pried steel coils from wood, 1 unit at a time. In an 8-hour shift, a skilled crew might process 40 mattresses. Meanwhile, 50,000 new ones were being thrown away every single day. The economics were brutal. A ton of scrap steel might fetch a couple $100, and a mattress only held a quarter of that value. Most recyclers couldn't justify the labor costs. So, the beds piled up. Landfill operators hated them because the springs tangled in compactors and ate through expensive machinery. Fire departments dreaded them because foam mattresses burn hot and fast in waste fires. Cities started banning them from curbside collection. The problem was becoming impossible to ignore, but the solution stayed stuck in the same bottleneck. You couldn't shred a mattress without gumming up the blades, and you couldn't separate the materials fast enough to make money. Then, in the last 5 years, a handful of engineers and recyclers decided to bet everything on a different approach. Instead of humans dismantling beds, they would build machines that could chew through an entire mattress in under a minute. The first prototypes were built in small warehouses in Connecticut and Minnesota, where teams like True North Goodwill had already spent years recycling over 3,000 tons of mattress steel by hand. They knew the profit was there if they could unlock the speed, so they designed a multi-stage shredding system that first grinds the mattress into chunks, then magnetically plucks out the steel while blowers separate foam from fiber. The new automated line at Casella's facility now processes 32 pocketed coil units per hour, a pace no crew of humans could ever match. But here's what the inventors didn't anticipate. The race to scale up these machines collided with a hidden reality. The waste stream was growing much faster than the recycling capacity. And inside the shredder itself, one component of the mattress was silently destroying the very machines built to save it. The component was something mattress companies had spent millions advertising as the ultimate breakthrough in sleep technology: the pocketed coil. Unlike the old open coil systems where springs were linked together like a cage, pocketed coils are individually wrapped in polypropylene fabric sleeves. Each spring moves independently. No sagging, no motion transfer. For sleepers, it was a revolution. For recyclers, it was a nightmare. Here is why. In a traditional inner spring, you cut it open, snip a few connecting wires, and the steel skeleton falls apart. But pocketed coils are engineered to never separate. Hundreds of small steel springs are stitched into long chains of fabric tubes, sealed with ultrasonic welds, and glued between layers of foam. To extract the steel, you have to tear apart every single pocket, one by one. The fabric itself is a synthetic that melts and smears across shredder blades. The foam gums up the rotors. The springs, freed too soon, become shrapnel that can puncture hydraulic lines. For years, automated systems simply could not handle them. Before the new shredder designs arrived, the biggest mattress recyclers in the country were doing the unthinkable. They were landfilling pocketed coils by the truckload. Casella Waste Systems, operating one of the largest mattress recycling facilities in the Northeast, estimated it was disposing of 40 tons of pocketed coils every single month because they had no way to process them. 40 tons of perfectly good steel buried in the ground because the fabric wrapping refused to let go. The very innovation that made beds more comfortable was undoing decades of recycling progress. Then, in a small industrial park, a company called Pocket Coil Recycling built a purpose-built machine to solve exactly this problem. It used counter-rotating shafts with hardened teeth to shred the fabric without cutting the steel. A magnetic drum then pulled the liberated springs from the shredded mass, while a series of air knives blew away the lightweight polypropylene. The machine could process 32 pocketed coil units per H-hour, a pace that made manual disassembly look like a horse and buggy. Casella installed one in late 2023 at their Willimantic facility, and overnight, those 40 tons of waste turned into 40 tons of saleable scrap steel. The dominoes started falling. Other recyclers scrambled to adopt similar systems. The Mattress Recycling Council, which funds programs through a small fee collected at every mattress sale, began pushing for more automated lines. The vision was clear. If you could automate the shredding, you could recover 80 to 95% of every mattress. The steel would go to mini mills and become rebar for bridges and skyscrapers. The foam would be ground into carpet padding and gym mats. The cotton and wool would become industrial insulation and mechanic wipes. A single recycled mattress could supply enough steel for nearly 40 feet of highway rebar. When you multiply that by millions, the numbers were staggering. But here is the catch. The shredders were now fast enough, but the waste stream was mutating again. A new category of mattress, one that promised to be greener and more affordable, was flooding the market by the tens of millions. And inside its layers lay a material that no shredder, no matter how powerful, could safely touch. The material was fiberglass, and the new mattresses flooding the market were the so-called bed-in-a-box revolution. The memory foam models sold online, shipped compressed, and unpacked in millions of bedrooms. To meet federal fire safety standards without using expensive chemical retardants, manufacturers wove thin strands of glass fiber directly into the inner covers. As long as the mattress remained intact, the fiberglass stayed sealed away. But the moment that mattress hit a shredder blade, the trap was sprung. When a fiberglass mattress is ripped apart, millions of microscopic glass shards are released into the air. They coat every surface in a facility. They get sucked into ventilation systems and blown across neighboring workstations. They embed in clothing, skin, and lungs. Workers complain of rashes that last for weeks, of burning eyes that won't stop watering. The fragments are so fine, they can travel through walls. And once they contaminate an entire batch of shredded material, that batch is ruined. Steel coated in glass dust becomes unsellable scrap. Foam and fiber contaminated with fiberglass can't be repurposed for carpet padding. It all has to go to the landfill. The recyclers didn't see this coming because they never had to. Traditional innerspring mattresses used cotton or wool barriers, materials that rot and burn but don't shred into permanent respiratory hazards. But by 2021, bed-in-a-box models had captured over 40% of the US mattress market, and most of them contained fiberglass. The recycling industry was suddenly drowning in a product it couldn't safely handle. Facilities that had just invested millions in automated shredders began facing a terrible choice: turn them off or poison their own workers. One facility operator described walking through his sorting floor after an undetected fiberglass mattress went through. He said, "It looked like a light snow had fallen indoors, except the snow glittered, and it was getting into the electrical cabinets, the break room fridge. The cleanup cost ran into the hundreds of thousands, and they were lucky no one ended up in the hospital." The deeper you dig, the darker it gets. Because fiberglass contamination isn't just a workplace hazard. It's a legal minefield. Recyclers that unknowingly process contaminated material can face lawsuits from employees, from buyers of their scrap who reject shipments with glass shards, from insurance companies that refuse to cover related claims. Some facilities quietly stopped accepting any mattress they couldn't identify on site. Others began requiring brand and model verification before they'd even open a truck. The grand promise of automated recycling was stalling in the face of an invisible enemy, And then came the realization that shattered any remaining optimism. The fiberglass problem wasn't an accident. It was a direct result of the same cost-cutting logic that had made pocketed coils so hard to recycle. The cheapest way to pass a fire test, just like the cheapest way to build a comfortable spring unit, had produced a product that was nearly impossible to safely dispose of. The entire mattress industry had engineered its way into a corner, and the recyclers were the ones left holding the pieces. Now the industry is at a crossroads. The mountain of waste is still growing. The machines have finally gotten fast enough to handle the volume. But unless the fiberglass crisis is solved, those machines could become the most efficient way to shred a recyclable mattress and still send it to a landfill. The question is no longer whether we can recycle a bed, but whether we'll be allowed to. But the answer, it turns out, is not a hard no. The machines are not stopping. They are evolving. Facilities are installing detection arrays, cameras, and sensors trained to spot the telltale shimmer of glass fiber before a mattress ever reaches the shredder throat. Workers suit up in full-body Tyvek with powered air-purifying respirators, and entire recycling floors are sectioned off into negative pressure zones so that any fiberglass release is contained and killed at the source. The cost is enormous, but it is cheaper than landfilling 40 tons of pocketed coils every month. And at the heart of this brutal economics sits the shredder itself, running 24 hours a day now in the facilities that can afford to keep it fed. Here is how it works. A mattress arrives on a lift, still smelling of someone else's bedroom, and a worker gives it a visual sweep. If it passes, it goes straight onto a belt that climbs toward a pair of counter-rotating drums studded with teeth. In less than 60 seconds, that bed, all the foam, all the fabric, all the wood, is reduced to a stream of confetti-sized chunks. Then the magic happens. The stream passes under a magnetic separator, a spinning drum of rare earth magnets that yank every shard of steel out of the chaos and drop it onto a separate conveyor. The steel, now clean, feeds into a baler that compresses it into 3-foot cubes, each one weighing over 1,000 pounds. Those cubes are loaded onto flatbeds and driven to a mill, where they are melted down and poured into new steel. And here is where the scale becomes hard to believe. A single mattress can yield enough steel to produce nearly 40 feet of rebar. A single recycling facility, like the one operated by True North Goodwill in Duluth, has processed more than 3,000 tons of mattress steel from over 320,000 beds. That steel has gone into roads, bridges, the frames of schools and hospitals, structures that people walk through every day, never knowing they are made from old box springs. The foam and fabric have their own second lives. Polyurethane foam is shredded into cushioning for carpet underlay. The cotton and wool become insulation bats and industrial wipes. Even the wood from box springs gets ground into mulch. The mattress that a decade ago would have swallowed 23 cubic feet of landfill for a century can now be 95% diverted. Its materials circling back into the economy in forms no one would recognize. But here is the detail that still feels like science fiction. If the United States recycled just half the mattresses it throws away each year, half of those 50,000 daily discards, the steel recovered would top 800,000 tons. That is more than the entire steel output of some small nations. It is enough rebar to build a concrete ribbon stretching from New York to Los Angeles. And it is sitting right now in bedrooms across the country, waiting for its second act. Which brings us back to where we started. Every night, America goes to sleep on a fortune, and every morning it wakes up to throw it away. The shredders are ready. The question is no longer whether we can recycle a bed, but whether we will choose to. The bed you sleep on tonight contains a piece of the future. 25 pounds of steel that could hold up a building, foam that might become the carpet under someone else's feet, fabric that could insulate a home. The shredders are no longer the bottleneck. The economics, the machines, the workforce, they have all arrived at the same moment. The only thing still lying between a mattress and a landfill is a decision nobody has fully made yet. A decision to design beds that can be taken apart as easily as they are put together, to hold manufacturers accountable for the full life of what they sell, and to treat the 50,000 beds we discard every day, not as trash, but as raw material waiting for its next assignment. If this story changed how you see what you sleep on, hit that like button, subscribe, and turn on notifications for more inside looks at the hidden industries that shape our world. Thanks for watching.